Hey, fourth graders, it's Mrs. Spears. This is lesson 11.2, and it is Tuesday, May 19th. This lesson is called Degrees, and basically this is where we start to take the connections between angles and numbers. We've really just been doing a lot with comparing angles and sizes and shapes and that kind of thing with angles. But now we get into the fact that each angle also has a number measurement that goes with it. So that's what we're starting to dig into today, and we're going to kind of continue with that for the next several days. So this is page 607, and I'll get started up here. This section is really important up here, so I'm going to read through it with you. It says you can use what you know about angles and fractional parts of a circle, so like the fraction pieces in a circle, to understand angle measurement. Angles are measured in units called degrees. Like it's kind of like degrees outside, like temperature, but not at the same time, but same kind of word. Think of a circle divided into 360 equal parts. So instead of having like yesterday's video had these little guys in it, instead of having like 1/4 size pieces, imagine that there's a circle that has 360 pieces in it instead of just 4 or just 8 or just 12 or something like that. So a circle with 360 teeny tiny little pieces. And they actually drew one of those teeny little pieces right here. It looks like it's just a line, but really it's a piece. It's just kind of hard to tell because it's so small. But if you take each of those sides of those pieces and extend them outwards, they do form a little tiny little gap, which is that angle right there. An angle that turns through 1/360th of a circle. So like, remember yesterday we talked about turns, and we took like the 1/12 size piece and we turned it all the way around. It's like this. This is going to be a 1/360th size piece that we turn all the way around 360 times. So it's the same idea, it's just much smaller pieces. The angle between the two spokes on the bicycle wheel turns through 10/360th, sorry, it's kind of hard to say, of a circle. What is the measure of the angle formed between the spokes? So it's thinking about, like, pretend this is a bicycle wheel, and like the two edges of this angle are like two of the spokes, two of the metal sticks that connect the center of the wheel to the outside of the wheel. So this is actually 10 degrees, 10 sections, 10/360ths, because there's 10 if you count, so there's 10 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They just had to make it bigger so you could actually see them, but that's 10 of those 1/360ths. So each 1/360th turn measures 1 degree. So each fraction piece in that, each 1/360th is 1 degree of a circle. And then 10 1/360th turns measures 10 degrees. So the measure of the angle between the spokes is 10 degrees. And that little tiny circle right there is the mathematical symbol for degrees. Okay, so I'm going to turn the page. This is page 608. And then it's got another one for us to look at up here. So it says find the measure of a right angle. So this is a right angle symbol, which we know from other lessons that we've had. The little the little square means it's a perfect right angle. It's perfectly up and sideways. Through what fraction of a circle does a right angle turn? Well, yesterday we talked about how that's 1/4 of a circle. So if we were to have a right angle plus another right angle, that's another 1/4, plus another right angle, that's like these little guys right here. That forms a perfect right angle. And the way you can tell that is if you compare it to like the corner of your book like this. It makes a perfect corner. So 1/4 of a circle is a perfect 90-degree angle. Through what fraction of a circle does a right angle turn? It's 1/4. So that's what we learned about yesterday. So now we're we're connecting angles with the fraction pieces that we know. Write 1/4 as an equivalent fraction with 360. So I'm trying to figure out, in circle terms, I can't say that this section right here is 1 degree. Because yes, it's one section, but that's 1 out of 4 if you divide it into 4 sections. degrees of a circle have to be divided into 360 pieces in order for it to count as a degree. Everything else is just a regular fraction. So we have to find an equivalent fraction that has a denominator of 360 to match, so we can actually figure out the degrees that this angle has turned. So I have to think 4 times 9 is 36. So I know with the 0 rule, I just pop a 0 on that. So it has to be 4 times 90 to get 360. So that's kind of, we have to figure that out. So that would be 4 times 90 to get 360. So it'd be times 90. Whatever you do to the bottom, you have to do to the top. So I'm going to multiply the top by 90 as well. So that means that this turn went 90 360ths of a circle, which is really weird to say. So 1/4 of a turn is the same thing as 90 360ths. These are your equivalent fractions. It says write 90 360ths in degrees. So an angle that turns through 1 360th of the circle measures 1 degree. An angle that turns through 90 360ths of a circle measures 90 degrees. So the reason I can match those up like that is because the denominator is 360. I can't do that with any other kind of denominator. So if I have a different kind of denominator, let's say they gave me 1/8 and I have to figure out how many degrees that is, I have to turn that into a fraction with 360 as the denominator before I can start thinking about degrees. I can't get to this point until I've thought through that process. So a right angle measures 90 degrees. So you probably heard me mention a couple times in old videos, when I'm talking about right angles, I talk about 90-degree angles. And this is where this comes from. It's exactly 90 degrees wide. All right, it says find the measure of a straight angle. Remember, a straight angle goes all the way across, just like in this picture over here. Through what fraction of a circle does a straight angle turn? Well, we know that that's half of a circle. We've learned that in other lessons. Half. Write 1/2 as an equivalent fraction with 360 in the denominator. Because again, I can't turn this into degrees until my denominator matches 360. So 1/2 of 360, what times 2 gives me 36? Well, 2 times 18 is 36, so that means 2 times 180, pop a 0 on there, pop a 0 here, means that I need to multiply by 180. So 1 times 180, because whatever you do to the bottom, you have to do the top, is 180. So a straight angle measures 180 degrees. Like I said, now that this fraction is with 360 as the denominator, I can actually use that number for the degrees. I can't use the degrees until I have a fraction with that denominator. How can you describe the measure of the angle, an acute angle in degrees? So I know that an acute angle is anything smaller than a right angle. And we've learned that in the past. We could find an acute angle by using the right angle as our reference. We would draw a fake right angle and use that to test it. So an acute angle is anything that measures smaller than 90 degrees, but can't be 0 degrees either, because 0 degrees means it hasn't moved any at all. So an acute angle measures less than 90 degrees, because it's less than a right angle, which is 90 degrees, but is greater than 0 degrees. How can you describe the measure of an obtuse angle? Well, I know an obtuse angle is bigger than a right angle. It's wider than a right angle, but smaller than a straight angle. So I know a straight angle is 180 and a right angle is 90. So an obtuse angle would be between 90 and 180 degrees. So an obtuse angle is between 90 degrees and 180 degrees. All right, I'm on page 609. Find the measure of the angle. Through what fraction of a circle does the angle turn? So again, the whole process with this is to find the equivalent fraction with 360 as the denominator, and then you can take the numerator and use it for your degrees. You just have to make sure it matches first. So it says that 1/3 of the circle has turned. So what fraction of circle is angle turn? It turns 1/3 of the circle. So 1/3 there. Started here and went this way apparently. So I have to think 1/3 equals something over 360. How many degrees is this? This angle right here will determine how this equivalates out. So what times 3 gives me 36? Well, 3 times 12 gives me 36. So I put my 0 on there. It would be 3 times 120 is 36. So this would be times 120. Whoops. So I need to do that to the top too. Times 120. So I have 120 over 360 is my degree measurement. So the measure of the angle is 120 degrees. If you're not sure about this part right here, if you're not sure about like what number of times would get me that, you can always divide. Remember, division's the opposite. If you're not sure about the multiplication, use the opposite operation of division. So you could do 360 divided by 3 to find out what that magic number is there, and then use it on the top. Okay, so this one says, tell the measure of the angle in degrees. First, I check to see, is my fraction, does it have a denominator of 360? If it doesn't, I have to make it equal that. This one's already at 360, so I don't have to do any kind of conversion like this. I can just use what's there. So because this is already 360, I know that the degree measurement of this angle right here is 45 degrees. With this one, if I check it, this fraction is in twelfths. I need to have it in 360. So I'm going to have 1/12 equals something over 360. I got to think, what number times 12 gives me 360? Well, I can have a 0 on the end, use that 0. What number times 12 is just 36? Well, that's just 3. So 12 times 30 gives me 360, which means 1 times 30, because what I do to the bottom, I have to do to the top. And that becomes 30. So now that my fraction's in degrees, it's in 360 with the denominator, I can use that top number to describe the degrees. So the measurement of this angle right inside here is 30 degrees. Tell the measure of the angle in degrees. So this one started here and went all the way around. The fraction's already in 360, so I don't have to change anything, which means this has gone 360 degrees or 1 whole turn. But with these, we just write them as 360. Have you ever heard of somebody saying, oh, that kid made a 360 or whatever? That means that they just turned around and then went right back the same way the same way they were going the first time. If somebody made a 180, if you heard somebody say that before, it means they've turned and gone back the other way than the way they were. So instead of facing this direction, they were going and facing this direction. So that's where those sayings come from. Check out this one. This one is in tenths. I need it in 3/60ths. So I'm going to turn that fraction into 360. Again, I don't know what times 10 gives me 360, but if I put the 0 down, I have to think, what times 10 gives me 336? Well, nothing. But here's the thing. You're like, well, this doesn't work. That's not true. That doesn't mean it doesn't work. But what it does mean, because I can't use that 0 rule that I was using before. Well, if I could, I took both the zeros off. So what times 1 is 36? Well, it would be 36. But I think how many tens are in 360? It's 36 tens. Again, you're not sure about any of that. It's okay. Just use some division. 360 divided by 10, and that'll give you 36. So you got to do it to the top too, which means you have 36 on the top. Because my fraction's in the right form, I can use the top number, and the degree measurement of that is 36 degrees. Okay, sometimes you're going to have to classify angles based on just their numbers. Now, hopefully at this point, you're able to look at this angle, this angle, this angle, this angle, and telling me exactly what kind of angles they are without looking at the numbers. But the goal of this right now is to get you to connect some of the numbers to the shape too. So I'm actually going to use these ideas over here to help me with this. I'm going to pretend those pictures aren't even there just to help me practice a little bit. So this is 127. Well, 127 is bigger than 90, so it's not an acute angle, and it's not a right angle, and it's not as big as the straight angle, which means it's an obtuse angle. And like we learned about last week, it's an, obtuse. We learned that if we did like a fake right angle, we took like a little piece of paper, laid it across there, make a fake right angle. That's bigger than the right angle, not as big as a straight angle. It's over in this area over here, which means it's an obtuse angle. This one's already marked for us, so we know that this one is a right angle. That one's easy. So this one is 37 degrees. It's, let's see, if we go over to the rules, it's greater than 0, but less than 90 degrees, which means it's an acute angle. And 180 degrees, we know that a straight angle is 180 degrees exactly. So that means that this one is a straight angle. Okay, so it wants to know if this picture right here is an obtuse angle. And it's actually talking about this angle right here. Not this one, but the shaded part. It's always talking about the shaded part with some of these. So it says, isn't it an obtuse angle? An obtuse angle is between 90 and 180. Your 180 mark is right here. That's your straight angle. This goes even past that. So this is not any one of the angles that we know from before. This is a weird angle. So it doesn't really, it doesn't have a name that I know about. So this would be no, it's not an obtuse angle because it's greater than 180. Which greater than half. So he can at least tell me that much. You don't know what the number is exactly, but you know it's at least bigger than half. And half is 180. All right, Alex cut a circular pizza into 8 equal slices. He removed 2 of the slices of pizza. What is the measure of the angle made by the missing slices of pizza? So if he took 2 of the 8 pieces, that would be 2/8. I got to figure out what degree that is. So what's the measurement of those 2 pieces of pizza? Think of like he ate, I'm not saying it was a 12th, but he ate like 2 pieces of these pizzas to put together. I'm going to figure out what that angle is. So I'm going to turn it into 360. With this one, I can't use the 0 trick with this one because nothing times 8 gives me 36. So if you go off to the side and do some division, do 360 divided by 8. 8 goes into 360 45 times. So 8 times 45 is 360, which means I have to do that to the top times 45. So 2 times 45 is 90 degrees. So hopefully that catches your eye. And you know that 90 degrees is the same thing as 1/4 of the pizza, which you know already that 2/8 is the same thing as 1/4. So you could also have thought of it this way. I know that 2/8 equals 1/4, and I just know off my head that 1/4 of a circle is 90 degrees. I mean, you could have thought about it that way too, but this way matches what we've been doing up here. That's up to you how you think about it. But the answer is 90 degrees. That's what the answer is to the question. All right, guys, I'm going to stop your video. If you join me for Zoom today, like I said, today is May 18th. You join me for Zoom, and I'll do this page with you. If not, you need to do it on your own. And you can message me with any questions that you have. I will see you guys in the next video. Bye!